turning into ohms. Null. You need to see that symbol here. Yeah, that means it's null. It was null, but now it's gone, so I have to null it again. Symbol is gone, pressing again, now it's null. You see it's flashing. That means null. What does it mean? Zero in the lead. You don't want to know.
No resistance.
Information about the lead. Yeah? So we zeroed it out. Right, how are we going to do the bonding then? What kind of test is the bonding? Is it long lead or R1, R2? Are we checking R2?
It's long lead on this one, no?
Yeah, it's long lead. Yeah, there's no R1, so we can't link to anything. It's just only one. What's the rule of the bonding? You tell me what to do. I'm like a droid, and you give me the information.
Bonding yet, mate.
Haven't done any. Haven't tested the bonding.
No, I haven't done any bonding. He said we're doing it next week.
Oh, okay. Yeah, okay. We should start with this test then. Yeah. Right. How we test the bonding? You need to disconnect one side, and ideally, I would disconnect the in the consumer unit. Yeah. There you can write down. Because if you already assemble these, I would not bother these. Mostly when we have the old type of connection. Yeah, it's even worse. This is nice and new one. Yes, one side needs to be disconnected. The reason why we have to disconnect is called parallel paths. Yeah, so if it's on, we have lots of earths and other bondings and supplementary bonding. You are testing all of them. Yeah, and that is gonna give you a good or bad value. So if you leave it on, is it going to be lower value or higher value?
Higher.
Lower. Yeah, and this is the problem because what does parallel path? If you have 1 ohms and you connect parallel to another ohms, what's gonna be the result? Half ohms. Yeah. So if you have the parallel path when you're measuring, I have satisfying results. It should be below 0.05. Another information. Yeah, minimum 0.05 ohms for the bonding. If you keep the parallel path, you are fooled. Oh, I have bonding. It's fine. It's safe. Yeah. No, but you might not have the bonding. You might have lots of other parallel earths and stuff, but not the bonding. Yeah, and that's where the risk is. You have a 0.03 ohms, which would be satisfying, but you are not measuring the bonding. So, yeah. So if I disconnect, so I eliminate all the parallel path. Obviously, common sense, I can put a crock on the end. Sometimes these crocks are funny. I have to check this one. Yeah, that's fine. It works. You put on a crock. One test needs to be on the screw, for example. Yeah, 0. We don't write 0, we write 0.01 as a minimum. Yeah, smaller than 0.01. This is just common sense. If you put this into nitrogen and cool it down to minus 273, I believe this is 0. Yeah, supraconductor. We don't have 0, it's just the accuracy of this device. Yeah? So one test on the clamp and another test just close to the clamp on the pipe or on the work. Yeah? Structural framework of the building or anything. Yeah? Why?
To make sure there's nothing running through it.
Yeah. You know, on the inspection and testing, there will be faults on the circuit, and maybe the inspector will put a tape around the clamp to make sure you are testing correctly then. Yeah? There would be no test results in here if there was an installation tape on the pipe. And if you fit the clamp onto the pipe. You agree with that?
Mm-hmm. Yeah.
So just the bonding, quite a lot to learn. Yeah, want to disconnect it to eliminate the parallel path. Then to test twice, and actually all of them need to be tested. So that one as well, and this one as well. All need to be 0. Yeah, or maximum 0.05 ohms.
What if it's more than that? If it's more than 0.05.
We have to deal with it. So let's have a look, for example.
You said minimum.
I would go for the easy one first, checking all the connections. Yeah. If you still don't have enough, maybe if it's too far away, maybe the 10 mil is not enough. You need to change it to 16. Yeah. So if you have value but not low enough, like 1 point something. Yeah. Tweak all the connections first. Have a look at these ones as well. Yeah. And then move on. Have a look at the on-site guy calculation. What's the maximum for the 10 mil? It's around 25 meter if I remember well. That should be about 0.05. Yeah, stuff like this. Yeah. Another rule about the bonding. If we talk about the bonding, we're gonna do the bonding anyway. Yeah. I've done with the B group now. I remember. Bonding is always continuous, so we don't interrupt. We don't cut the wire here. We strip the insulation off the wire, and then we connect them. Yeah. Okay, so that's all about bonding, but we're gonna do it anyway. When we do it, I'm gonna talk more about the theory, what the difference between the bonding and the earthing. Yeah, I don't want to waste time with that. If you don't want. Yeah, bonding done, well done. So we have 3 more tests only. Which one you want next? Lighting circuits? Yeah. Okay, let's do the lighting circuits. Obviously, these two. They don't apply, yeah? So we don't use them. There are only 3 circuits. Yeah? Obviously 6 amps should be for the lighting. And just like a busy bee, I start opening these switches. How many points you have to test? How many testing points do you have in this installation?
3.
3. Which one?
2 switches.
2 switches and ceiling rows. And I'm telling you, it's going to be really easy to do testing on your circuit because you're going to create a circuit. Yeah, I spent a few weeks with that, from rewiring everything and stuff, because it was in my circuit, so I had to get my head around it. There's lots of resistors are hidden. There are 10 switches, 10 volts are switched into the grid. Yeah, but if I had made that one, that could have been way easier because I was wiring it, so it shouldn't be hard. Yeah. You're gonna wire these, but just common sense, yeah. If it's not yours, for example.
So we've got to wire this halfway.
Yeah.
Okay.
You're gonna do exactly this, yeah. That's gonna be your.
So when we come to it, there'll be no wires in it.
When you come to the synoptic practical, my friend.
Yeah, but you've got to put everything on the wall, haven't we? that we've made?
You're gonna erect
Oh,
all
of course,
these,
yeah.
What you're gonna have on the wall, yeah. Marked red. Consumer unit. I think the pipes will be on.
Like trays there.
Yeah. These will be on.
Yeah.
Yeah. And this will be on. But that also means you are not allowed to remove it. Yeah. That's why you have to create a running coupler. Yeah. Because you're not allowed to remove these. Yeah. The rest you need to build. So you're gonna make a PVC conduit. These tasks are gonna scratch everything. Yeah. And you can come here as well. You can use this one as a demo.
Or you can come over and have a look.
That's a picture for that.
Yeah. The only difference is you have to come. Yeah, you're gonna enter from the top, not from here. Yeah, so you're not gonna have this band. I think this is even
So we
easier.
won't be working on this actual board, then we'll have another board.
You're gonna work on these.
You'll be doing it in your bay.
Yeah.
Yeah. So guys, okay, let's make it clear. One person, one bay. Yeah, on the painted wall. This is tech level 2 right now. What they're doing, that's tech level 2 in the morning for this 17, 18 years olds. Yeah. Okay, that's what they are building now. Is that all right? Yeah. So if you see, the only difference is you have to do 2 90 bands. Yeah, you're not gonna have these. This will be longer. The consumer unit will be only a freeway consumer unit, small one. Yeah. Okay, cool. What's next? It's already disconnected, yeah. Obviously, the neutral shouldn't be disconnected. Somebody took it off, so I put it back now. Sequence number 3. Yeah. Because main switch number 1, number 2, and number 3. Yeah, same on there as well. Sequencing, that's one of the criteria when we do the feedback. We are looking the, if we do the marking, we look in the sequence.
Sorry.
Yeah.
Do you know there's 91 over here? Do we need to do this little bit like?
No.
I mean,
No,
okay.
don't have to do. It's just a 19, it fits in perfectly then. Yeah, you're gonna put cellulose. Okay, right. What's next? What's the next step?
Yeah,
Link.
CPC to line.
Yeah.
So it's a link method.
Yeah. If you have a line as CPC, it's called R1 and R2. Yeah. R1 is the line. R2 is the CPC. What's next?
We use the prongs on the ceiling rows and test between line and CPC.
Nice one, yeah? Yeah, don't slide this one. Yeah, let's put it on the. Try to keep the crocks on the lane, yeah? Line and CPC doesn't matter which way, yeah? You're just checking on the resistance. I like putting the brown one on the line and the red one on the line and CPC. Oh, I don't have any results. What do I have to do?
Switch the switch. Switch the switch.
Yes, switch it off. Yeah, so now I have results. Other one as well. Yeah, so you have to write down, that's your first result. Yeah, writing down on a dummy, you're not writing down on the generic test result sheet. Yeah, because how many spaces do you have on the generic test result?
1,
Only 1. Yeah, how many tests do you have to do?
3.
3 tests. Probably you believe it now. Yeah, 0.01.
So you're testing there between Earth and between CPC and Common, yeah?
Yeah, always. So just common sense. If you link line and Earth, what you looking? Line and Earth.
Yeah.
Yeah. All the time, just systematically doing exactly the same.
What readings were you getting?
Yeah, 0.01,
Yeah.
0.05,
It's a small set.
1.25. Oh, 1.25. What will you do?
Well, there's a connection issue.
Connection. Tweak the connection. Make sure it's fine. Also, flip the switch a few times. Maybe it's just full of dust.
How did
Yeah.
we get 22? Yes, on you.
22 ohms.
22 on.
Yeah, more probably the switch. Yeah. Or you look, you start pushing the switch and it goes down to 0.1. So that might be the switch.
Well,
now.
what reading
Yeah.
are we looking for?
Low reading. Yeah. 0.01. 0.02. Yeah. Because you don't have not much wiring in here. Yeah. You have only 0.01. But if these switches are on a corridor,
Yeah.
yeah, you're never gonna get 0.01 in real life.
No.
Yeah.
What's
You can
that
have, sorry,
maximum?
you can have 5.85 ohms ZS. Yeah. 6 amps type B circuit breaker from the on-site guide. Yeah. If it's higher than that, not complying, because TNCS, that's fine. It's all 0.35. There's lots of benefit in there. The rest can be R1, R2. Yeah. But if you have TNS, that's 0.8. Yeah. You have to minus that from the 5.8. So you still have 5 ohms to play with.
We haven't done TNS yet, have we? We haven't
No.
done any of that yet, mate.
Bloody hell, you're behind.
Yeah. That's great for
He's
you.
gonna
He's going to get a car started again.
Yeah, you're gonna start having extra.
Don't get me started on grade.
Not being funny. If you have any questions, you can bring it to a small classroom because practical we are way ahead.
Yeah.
Yeah, only the bonding left. Thanks for reminding. Yeah, but everything else is done. So if technology is a bit too tough for you because you're gonna have the exam, I'm here to help. Any question you can bring me like randomly. Yeah.
And the next session.
Every week,
Yes.
every night next week,
Come on.
yeah?
Oh, hang on. Next week. Still.
I'm joking.
Yeah. What is the maximum ohms it's okay. Like,
Well, on your rig,
Yeah.
when you build up,
yeah.
there's no such.
Okay.
Yeah.
So like, if it's like, I know it's like, if it's more than like 1 ohms, then there's something wrong with that. But like, in generally, like, what's the maximum it goes
There's
to?
no any maximum like this.
Okay.
Yeah. So if you have 20 ohms,
Yeah.
we might give you another switch. Yeah.
Yeah.
To be fair, it should be all new switch, but
Yeah.
this thing should switch all the time. Yeah. So we can let's compromise a few ohms only. Yeah. So we're gonna help you to bring it down to a few ohms.
Okay.
Yeah, because that's your own installation. It's not really nice. We have 20 ohms because the switch has been there for 5 years. Maybe that wasn't the end of the, you know. Okay, any questions? What's next? From the continuity. that was-
Sockets. What do you want to do?
We still have to deal with these, yeah?
Okay.
Continuity, done.
Yeah.
Installation test.
The installation resistance.
So put everything back. Screw everything back
And then
up.
the polarity as well. isn't
Okay,
it?
just a bit of information. Now we put everything back, that's fine. You have MCB. Yeah? If you have RCBO, we don't zap the RCBO. This is electronic. Yeah? And you might damage the RCBO or you have a false reading. Yeah? And actually, my practice is, if something is out, I'm using the clock. I do the IRT as well. Try to minimize zapping any device.
Yeah, but if you're doing the insulation resistance test, you're not going to be any wires in there, is there? Anywhere to fry it, because you're going to have the wires out on the crocodile clips.
Yeah, yeah, but what we're testing, we're just testing only the wire. That's what we want to know. And what do we test when we test insulation resistance?
But the cables are good.
Yeah, okay.
Sorry,
Which part of
the
cable?
insulation's good.
The insulation is good, that's the core, yeah? So we want to make sure there's no any leakage, yeah? Because the current will not go into the end. Oh, there's a little gap here, yeah, between the line and the earth, so I'm passing. I'm going back to the transformer.
Okay.
These electrons, they are so lazy, they just want to go home all the time. And their home is the transformer. And they just sending again, come on, go again, yeah? It goes with the speed of the light, yeah? If you were an electron, while the current is running, you are here, and in a fraction of a second you are already back again from the transformer. Yeah? And actually it's not the electron moves, if you bit of physics, yeah, it is just knocking each other, giving the energy to each other. Yeah? It's mind blowing if you go into the physics of this. Absolutely. Yeah? Anyway, yeah, so I leave them out. I'm gonna do I'm gonna zap them with the crop. I can do the line and off straight away.
This is IRT now.
Yeah, IRT 500 watts. Yeah?
You haven't put everything back yet.
No. That's what I'm saying now. You're testing the cable. Not the best crop. You see the gap, I don't really like this crop. Doing like this when you eat something like
He said that you've got to put everything back before you do the
either or. Yeah, but if I've done the continuity and the cables are hanging out, I'm just doing the 500 volt IRT as well straight away.
So you don't need to put the switch back or anything like that?
Oh yeah, these ones should be going back. Yeah, but I leave them open because I'm gonna think it. Yeah, did you mean this one?
Yeah.
Yeah, that's fine. Good call. Everything should be back. Yeah.
Before you do your
Yeah.
IRT.
Before you do, yeah, okay. Put as a comment, but I'm
Yeah.
not doing it now. Yeah. Everything needs to be back. Yeah, that's fine because somebody might be there and just kind of zap. Yeah. And what reading do we want?
Greater than 1000.
Yeah, greater than 1000. Yeah. Neutral is there. I'm not gonna take the neutral off. I can use the bar as well. Yeah. Best crock ever.
It bites back, this
Right.
one, this
So
crock.
then, because of that, I need to keep it on. Oh, well, oh, that's fine. Yeah. Zap again.
Yeah.
Yeah, and neutral as well.
Did you have to null the leads before you do the IRT or no?
You don't have to
You
know
don't
the
have
lead. Bloody hell. Doing my heading now, I'm gonna get. This is really bad quality of crocodile, yeah? Neutral to off. You don't have to null the lead. So this has more functions. When you do continuity, this test button is just for nulling the lead. Yeah. But if you are in a 500, this test button you need to hold it exactly the circuit. Is that all right?
So you
Yeah.
just check there, line in CPC, neutral in CPC.
Yeah.
Yeah.
Line to off, line to neutral, neutral to off.
Yeah.
Yeah.
Line to neutral.
If you want to test the installation resistance, yeah, you can put them together. Test, it should be 0. Yeah, also because there's a short. Yeah, and then you can test just connecting them, it should be over 1000. Yeah, just testing the lead. Okay, any questions?
So are we not testing the commando then?
Yes, we're gonna test the commando as well.
That's
You want the
what,
commando next?
yeah, we'll do that now. Yeah.
Yeah.
So there's yeah, so there's 3 circuits in total, then, isn't there?
Yeah.
Commando, sockets, and switch.
Yeah, let's leave
Right.
the last one.
And bonding.
Bonding, done the bonding.
Yeah, so four areas then to test.
Oh, can't see what I'm doing.
Are we testing the spur as well? On the sockets?
Yes. Okay, so the spur is a part of the ring. Yeah. Let's test the commando. Yeah. Commando is a radial power circuit, 20 amps, yeah? Runs from an SWA. Which you need to sleeve, yeah?
This is the radial pattern.
Sorry?
Radial, yeah.
Yeah.
Does it have to be on an SWA? Could it be on?
Yeah, it's
Got to
gonna
be.
Yeah, it's got to be on your SWA.
Couldn't be on a 1 mil then.
You can bring your Wago, yeah, makes it quick.
So you're doing the same thing, the line and the CPC.
Yeah, again, it's always do the same thing. Yeah, link. Yeah, link. Okay. You just take the lid off the commando socket then, yeah? How are you gonna check polarity on the commando socket then?
Probe it.
Hmm?
Probe it.
No, just visual check.
Oh.
Yeah? It's favorite question of examiners. Don't get misguided. There's one L, yeah, L plus or something, and there's another 500 volts. Yeah? Sometimes you guys mix it up. The 500 volt is the neutral. This one you don't have it there. Yeah, yeah, 690 volts, yeah? But that's the neutral.
Does it say N on there, does it?
There's no N.
No N.
Yeah, sometimes there's no N, sometimes there is an N. Yeah?
So that says L, yeah?
Because you just will come and say, oh, 690 volts, so that must be the line. That's a huge mistake.
So you're
Yeah?
live on there.
Yeah? So live line, and then there's a little volt, that's 690 volts. Yeah? So be careful when you connect them. Yeah? The earth is an obvious. Earth, you're gonna see the +1 symbol. Yeah? So that's an easy one.
So what's that one for?
Just to make sure you connect them right. Yeah, so this is how you test. Again, just line and earth, yeah? What reading are you supposed to have? Low reading, 0.01.
Where are you putting it in?
Oh, yeah? No, honestly, you can come here and take the picture if you want. I don't mind. Yeah? Come here, I hold it on, line and earth, yeah?
Line and CPC.
There you go, take it off. That's a nice picture, you can see the result as well.
Visual check was for polarity, wasn't it?
Yeah?
Visual check.
Yeah, polarity, visual check. That's your learning outcome. Yeah? Any more pictures? No? Yeah? Cool. Any more questions? That's an easy one. That's the easiest one. Yeah? At the end of the day, whatever you test, line and earth connected, so you're testing line and earth. Yeah? And sometimes I don't understand why people are stressing around the testing. But that's fine.
I was, to be fair.
Yeah, good. Good. It's just more money for me, because I'm not stressing on testing, so I go and get the job.
Yeah.
Use the link over there.
Saturday, testing £300, that's it.
Yeah, he's linked it here.
Yeah.
And then test down there. On OMS, isn't it?
So you said we could tick polarity by just doing a visual inspection
Yes.
of the command.
Yeah, that's all you can do. Yeah, if you don't have switch to flip, you don't have choice. Yeah, but at least visually need to be checked. Yeah.
So we are DIRT that as well.
Yeah, you're gonna do IRT. IRT is gonna be the same.
Yeah.
So you have to do an IoT on that as well then?
Yeah. Just while you are writing down your notes, I put this on. 20 amps radial, yeah?
Yeah.
Waking up from your dreams, ring 32, 2.5, yeah? Radial 22.5, or 32.4, yeah? Yeah, you can have radial with 32 amps, yeah?
Yeah.
But then you need 4 mil cable.
And that's for commander, or was it?
No, it's just general.
General. Oh, sorry.
Okay. IRT? And now, because I'm not happy with the Crocs, I put them back, so I'm using the other one now. Yeah?
Straight into this switch.
Back into the MC.
So we can do the testing when you're doing the lead test with an MCB, not with an RCB. Or can you do it with
Yeah,
an RCB?
MCB you can connect back, there's no any harm.
But with, if it's an RCB, then you have to take the leads out.
RCB anyway, you have to take them out, yeah? Guys, just another one, just another little pause. Yeah, when you do your circuits, be an artist, yeah? If you twist and pull, you can have a look what beautiful connections you can have.
Do you get a higher rating in the exam?
Nah, you look at that.
Extra marks for
You just get
neatness.
maybe higher marks.
Oh,
Yeah?
If you put
Yeah.
ferrules on,
So look at these. Maybe that's too much. Yeah.
That'll be distinction plus.
Yeah, that's gonna be
ferrules
a
on.
over distinction.
Does that go into number 2 then, Tomas?
Yes, number 2 again. Yeah.
Like 32 amps for the
500 watts. Zap, zap, zap. Yeah.
This is general.
Line to neutral.
Yeah.
Look, chopstick method. Yeah. You hold it. You don't ask us, can you please press the button? No. You are the controller, yeah?
Okay.
So one hand, 2 probes, yeah, over 1,000. Look, I'm just flipping on to the number 2 and zap.
Little chopstick method, isn't it?
Yeah.
And then
I
neutral
call
to.
it chopstick method. This is my invention. Yeah.
But you can use the crocs as well, isn't
Maybe
it?
they will call it Tomas method.
Yeah, I'm not
Yeah, you can use the crocs as well. Yeah. Good question. Crocs are fine.
Not good with the chopstick.
Yeah. Over 1,000.
Because at least with the crocs, I know always
Look,
leave one
yeah?
on for another go.
No overthinking that.
I'm going to just use that because the crocs are a ball ache.
Right, and finally, the ring circuit. Whoa, ring. Then we slip
No,
again.
yeah.
This is the danger.
The danger. Ring. Disconnect everything when you do the ring, yeah? Even the neutral. Why do we need to involve the neutral as well now? We did not involve the neutral before, so why do we have to do? We don't connect, when you have radial circuit, we don't disconnect the neutral.
When we're doing each different one, do we have to, like, say if we finish with that, do we then wire that back in?
Nice one, nice question. Guys, did you listen to the question?
Sorry.
Yeah? The 20s, the guys in 20s. Good question. Do you have to reconnect everything? Yes, one by one. Do everything one by one. Don't
Leave it out.
leave everything out. You're gonna get confused. Yeah? Finished with one, reconnect, and dress nicely. Yeah, you want me to assess it. Yeah? Oh, that's another thing. We call it dressing. Is it dressed nicely? Sequence. Yeah, just in the consumer unit while we're looking. Sequenced. Right MCBs. Right, correct size of the cable, and dressed nicely. Yeah. You leave the cable long and you can toggle behind. That's why we have this DIN rail and you have space behind the DIN rail. Yeah, do a nice work. Yeah. See, all the cables should be behind, not in the front. Okay.
Can you use it? Tom?
Yeah, you can use zip tie.
Okay.
Yeah. Actually, really good practice. Yeah. Hold your question. Yeah. You're gonna have an issue incoming and outgoing. Yeah, because when you do the crosslink method, we should have one from the incoming and one from the outgoing, or one from the number 1 or the 2, or as already, so however you call it, but make sure it's gonna be the right match. I tell you a bit of secret in here, okay? What's the longest cable here? Less than 2 meters.
Yeah.
There's no effect. So whatever you choose, this will go down fine, so don't waste time with that. Is in the on-site guide, yeah, what's the minimum length? You have to worry about this. If you have a long cable, ring, yeah, and long means just a small kitchen with a ring power, that's you have to deal with that. Yeah, what you're gonna experience, if you had the right choice, yeah, you're gonna have pretty much the same readings everywhere. 4 points on this installation, 4 points, 0.05, 0.06, 5, 6, something like that. If you have the wrong choice, yeah, you have one maximum and there will be minimums, yeah. Okay. For you on the day, don't worry too much about this. Oh, did I have the right choice? But if you done the nice installation, it's good to have one of these using for the incoming, another one for the outgoing, and it just makes your life easy. Yes, question.
Do you know the lighting you were using sequence 3?
Are we going back to the lighting now?
No, like, do you know, like the fuse wise you mentioned like in sequence 3.
Yeah.
So what do you use for commander? What sequence? Did you use like 4 or?
Okay, right. Main switch.
Yeah.
Yeah, this is the 0, like call it main switch. Counting from the main switch. Yeah.
Okay.
Main switch is the 0, so that the closest to the main switch is gonna be the number 1. Yeah, and
The highest one.
highest rating should be close to the main switch. Yeah. So if you have 5 times 32 amp, it doesn't matter which order you do, but 5 times 32 amp should be the first ones. Yeah. And then you have the 20 amps. You put the 20 amps, 16 amps, 10 amps, 6 amps. Yeah. Good practice. That's all you need. Yeah.
So the lowest the lowest.
The lowest should be the furthest.
The furthest
from the main
away.
switch. Yeah. If you have dual RCD consumer unit, start again. So imagine there's an RCD here,
Then a switch.
32, 16, 6, and then there is another RCD,
Then
probably in a
start
house. Yeah.
Yeah.
And I have a 2-bedroom flat. I have dual, and then start again. 32, 20, 16.
Okay.
Yeah. And the numbers are following. Some of the obsolete consumer unit have this one on the left side. Yeah, main switch on the left, but then these numbering the
Go
opposite
that
as well.
way,
Yeah, so it helps you. Okay, right. Let's crack on these legendary ring testing. The first step is called end-to-end or loop resistance test. If you want, you can take a note of all these. Yeah. Line with the line. I hate these clocks. Damn. Hardly here. There we go. Switching into the ohms. Yeah. So 3 steps for the continuity. Yeah. Small R1. This is called small R1 test as well. Yeah. Small R1. So small R1 is not the same as the block capital R1. Yeah. That's the small R1 test.
So this is the continuity test, right?
Yes. Yeah. There will be some issue here because I don't have the reading now. I should have low reading. There's a fault somewhere. Yeah. Probably one of the wires disconnected then. Yeah. But what we should have in here is 0.0 something, which we don't have. Yeah. We might investigate this. I always double check. Isn't my lead? Yeah, it's not my lead. There's a fault in here. Okay. We move on now. We go to the neutral. We're gonna find this fault today. Yeah. Yeah, this one as well. Hang on. Let's do a quick test. Yeah, the earth is alright. Earth is 0.05. I have problem with the line and the neutral as well. We always double check. Maybe I'm having something else. Yeah, maybe I'm having the neutral line from the SWA. Yeah, which is not true. These are the ring. These are the part of the ring. Yeah, we're gonna find the fault in here. Okay.
Continuity.
No, I'm